Hey guys, so I know I'm starting this a little bit weird because I'm in front of the camera right now, but we're going to be doing 3.1, which is the chain rule. And you'll see after this lesson that now you can do more of the derivative packet because these are the ones that I had you skip for now. The reason why I'm not looking at the book right now is I want to show you a picture here. Let me share the screen. Hold on right here. Sorry guys, it's taking a minute. I don't know why. There we go. So this is what you call a Russian nesting doll. Okay. Some of you might have seen this in movies. I was trying to find the best clip for it, but it wasn't working out. So this is what I have to do with. And as you can see, if you don't understand what this is, what happens is when you buy one of these figures, you actually only see the biggest figure there, okay? Because all of them are inside each other, okay? Now, that is what we use the chain rule for. We use it because there's things inside that keep going and going. Now, some of us will get in the habit that we only see the one inside extra doll, but we need to be prepared for more. Okay, so as we learn this lesson today, I'm hoping that you can think of the dolls and one inside the other, okay? All right, so what we're gonna do is discover the chain rule here by using the product, okay? So we have function 1 and function 2. So the product rule is the first function times the derivative of the second function. The derivative of the second function would be 3x squared. Product is addition. The second function times the derivative of the first function. Okay, so now if we look at this, we have two of the same term. So in other words, we have 2 times x cubed minus 3 times 3x squared. Okay? Now, I'm going to rewrite that first function to begin with. What if we actually looked at this as x cubed minus 3 squared? Can you see a faster way that we could have started here and came up with this answer? Well, if you look, the outside, remember the dolls, right? The big doll, the outside is squared, and that's a power rule, right? So we bring the 2 in front and then subtract 1 from the exponent. And that's where we would get this part of the equation, our derivative. Now, where does this second part come from? Is there something you recognize for the second part? The second part is coming from the inside of the function. So this part is coming from the 2, and the inside here. Okay, now I'm going to summarize that up better for a rule for you. So the idea of the chain rule is the derivative of the outside, same inside, times the derivative of the inside. Okay, so example, we have a function within a function. So to take the derivative, we take the derivative of the outside function, leaving the inside the same, times the derivative of the inside, just like the doll. Excuse me. Sorry, guys. Okay, so it's going to take some time to recognize, and again, just like the dolls, there might be more than 2 functions, and we can completely go in and in. So take your time with this. I want you guys to recognize, like on number 1, we're dealing with two functions. I see we have a function that is to the fourth, and we have the inside function of 3x cubed minus 5x, okay? So to take the derivative of f of x, we're going to do the outside. The outside says, bring the 4 down. Inside stays the same. And then, of course, we would subtract 1 from that exponent. So that's the outside derivative times the inside derivative, which would be just our power rule. So that would be 9x squared minus 5. And we're done. Okay? I'm going to change colors since I'm running out of room. I think I'm writing too big here. So on this one, again, I see two functions. I see the sine function, and I see on the inside, I have a 3x function. Okay? So I'm going to do the derivative of the outside, which the derivative of sine is cosine, keeping that inside the same, times the derivative of the inside, which is 3. Okay. What we should be learning from our derivative packet and from last chapter is that sometimes before we take the derivative, we want to see if we can do any type of simplifying so it makes it easier on our problem. Okay. So for number 3, the first thing I'm going to do to make sure that I can do this derivative, because I almost feel there's 3 functions here, right? We have a square root function, we have a cube function, and we have this 2x squared minus x. That's a lot. But can we simplify it enough that maybe we don't have 3 functions? Well, let's think about this. What is the square root actually as an exponent? Well, the square root as an exponent would be to the 1/2. So if you look, I have 2x squared minus x to the 3rd. But now that square root, I'm going to rearrange that to being a half. Well, if you remember, when we have an exponent to an exponent, we multiply. So 3 times 1/2 is 3/2. So now when I look at it, I no longer have 3 functions. I look at as I have a 3/2 function to the 3/2 function, and I have that inside function. So when I take g prime of x, I'm going to do that power first on the outside, which is bringing that 3/2 in front. That inside stays the same. And I subtract 1 from there. So 3/2 minus 1 is 1/2. And don't forget, this is a chain rule. So I have to multiply by the derivative of the inside, which would be 4x minus 1. Okay. All right, let's look at this. Okay. When it comes to exponents in trig functions, usually they're going to be written something like this. But the first thing I want you to do is I want you to rewrite it. What I want you to do is rewrite it where the exponent is in our normal exponent place. Okay? So, first of all, the 3 out front is just a scalar multiplication, so we can just keep that out front. Our 2 functions then are the square and the cosine. So I'm going to do outside in. So the derivative, I'm going to do the exponent one first. Bring the 2 down. So that's 3 times 2 is 6. Keep that inside staying the same. And so that's to the first. I can write to the first, or I don't have to. Times the derivative of the inside. Well, what's the derivative of cosine, negative sign. It is perfectly fine to keep your answer like this, unless we were doing a multiple choice or like on your derivative packet, where I want your answer to look a certain way, because we can move that negative in front. Remember, this isn't subtraction. This is multiplying by a -1. All right. G of x. Could I do the quotient rule? Yeah, I could do the quotient rule. It's a lot of work and everything and a lot of simplifying, or I can do the chain rule. But before I do the chain rule, I might want to rearrange it so it looks a little bit better, because that means all of this goes together. And if I bring it up to the top, I have 2x plus 1 to the -1. So I have power rule out front as my outside, power rule as my inside, chain rule, right? So outside then inside. So G prime of x equals, bring down that -1, inside stays the same. You gotta subtract 1, so that gives me -2, times the derivative of the inside. If I look at 2x plus 1, the derivative of the inside is 2. Okay? Because this one's going to get complicated. I'm actually going to mark off some space. Okay? Because here's the issue. One thing I want you guys to notice is that we have a multiplication of two functions. Multiplication of two functions means the product rule. But if you look, we have an issue here because in a product rule, we have a chain rule, okay? So remember the other day when we were doing product rule and I said some people on the side want to put the functions and its derivative before putting it in the product? This might be the case, okay? So I'm going to label this as G of x and H of x, just so I can organize my work a little bit. So G of x I have as 3x squared. The derivative of G of x is 6x. Again, I'm separating this to make my product rule easier, because H of x, and I'm going to rearrange this a little bit, is 9 minus 4x squared, squared, to the 1/3. Let me write this a little bit clearer, because there's one thing I want to point out. In this case, I cannot multiply that 1/3 like I did up here with the 1/2. Okay? I have to see that this is a chain rule right here. The outside is to the 1/3. The inside is the 9 minus 4x squared. So when I take the derivative of that second function there, I get 1/3 times the inside. Remember, that stays the same. Subtract 1 from the exponent. That gives us -2/3. And remember, the chain rule says do your outside times the derivative of the inside. Derivative of the inside, 9 goes to 0. The second part is -8x. Now I have my 4 parts for my product that I can put it in my product form. You can either keep your exponents as what they are, or you can put it back in the cube root and all that stuff. That's going to be based on if it's a multiple choice or if it's open-ended. So I've got my parts. F prime x equals, remember, it's your first function times the derivative of the second function. You could simplify this if you want, but right now you don't have to. In the derivative packet you will, and in multiple choice questions you will. So I'm just going to write it as is so we don't get too confused. 2/3 times -8x. So let me reiterate what I just did. First function times the derivative of the second function plus the second function, oops, the second function times the derivative of the first function. Okay. See how I made a plan, I broke it up, I made it as simple as I could, and then I put it together, okay? Watch your steps. Okay, what did I say the first thing to do with trig functions were, especially if they had exponents? I said rearrange them so the exponent is in the usual exponent part, okay? So I have sine of 4t squared, that whole thing cubed. Now, does everybody see why I'm having you do that? Because if we were to compare dolls, right, we would have 3 dolls. Outside is cubed. The next level is sine. And the next level is 4t squared. I'm going to try to use colors so you guys can see a difference in the way I'm viewing things. I'm just wondering where my markers are. I guess I can. I wanted more of a highlighter thing because I don't want it to be too dark, but we'll see what we can do. Okay, so the outside is the cube. The next function inside would be the sine. And then the middle, the last function on the inside is that 4t squared. Okay, so ready? We're going to do the outside first. The outside is just a power rule. So we bring the 3 out front, keep everything inside of that the same. And don't forget to subtract 1 from that exponent. So that right there, that is the derivative of the outside. Now we multiply by the derivative of the next doll, the next function. Remember, the next function is sine of 4t squared. So the derivative of sine is cosine. Keep that inner function there. So this one is that second part. And then the third part is multiply again by the very, very inside, which is the 4t squared. So 4t, the derivative of that would be 8t. Yes, we're gonna, this is why I give you the derivative packet so you can practice a lot, okay? Now, what does that do for us? Okay, well, it helps us find the derivative of multiple functions within itself. Let's do one more example, and then you guys can do some practice. Okay, it says down here, you must quickly learn to distinguish between the chain rule and the product rule. I am reading this before these two questions for that purpose. As you can see, this right here is the product rule. There's a multiplication, where this right here is a chain rule because it's one function within another. So if we talk about the derivative here, remember the product rule says the derivative, or the first function times the derivative of the second function plus the second function times the derivative of the first function. So that would mean we want to go to this chart. So P of X, because we're dealing with 2. P of 2 is 5. Q prime of 2 is 6. Q of 2 is 3. And P prime of 2 is 7. You know what's great about this? If this were an FRQ question, that is your answer, and we are done. We do not need to calculate that. Okay? But if it's a multiple choice, it's probably going to be put down together. What is this? 30 plus 21 is 51. So our answer would be 51. Okay, that was product. Now let's see what chain rule will do. Remember, chain rule, let me get my notation correct. Sorry, guys. H prime of X is the derivative of the outside, leaving the inside the same. Okay, I'm going to repeat that. The derivative of the outside function, so that's why it's P prime, keeping the inside the same, times the derivative of the inside. That is the chain rule. Now let's put our stuff in. Well, 2 for X, we would get P prime of, well, Q of 2 is 3 times Q prime of 2 is 6. P prime of 3 is 8. And the 6 is still there. And of course, we can do that as 48 or just leave it as is. Okay, and that should be it. Yep, it is. You can start on your chain rule, get enough practice of this, and then you can do more of that derivative packet.